I want to take a moment to talk about a new kind of protocol that's being seen in more and more I/O devices. Now, I/O means input and output, usually meaning like contactors, solenoids, sensors, those field-level devices that get information and send actions back into the system. This protocol that I want to talk about is called I/O link, and it's actually a standardized protocol that is gaining a lot of traction, but it can be a little bit confusing, so I wanted to define what it means and a little bit about how it works. Now first, it involves a little bit more equipment. First, we have what look like fairly familiar sensors, and they actually can be used in many cases just like standard discrete sensors. These are a couple of optical proximity sensors. When we read the datasheet, we can see that they are I/O link enabled. Now that means that there's extra information that can be sent from the sensors, often about how the sensors themselves are performing, but we can also get multiple pieces of data back to our system through only one wire. We supply power, we supply ground, but that one signal wire, instead of just providing a trip point like a normal proximity sensor, instead we can supply multiple trip points, which can create a window or a range of operation. We can also get extra analog data. Analog means not only whether an object is within a field of view, but how far away it is as well. This is the difference between a proximity and a distance sensor. So by using this protocol, we've created a lot more flexibility in our system, even though we're still sticking with standard sensors. It's not only the sensors, the field devices themselves, that are necessary for I/O link, but the connectors, which normally use the standard M12 connectors, go back to an I/O link hub or a master device. An I/O link hub allows input of multiple I/O link and also discrete devices, so you can still use your old discrete devices, but they can also then be distributed back to a network like Ethernet or Profinet to communicate back to our PLC system. So instead of completely overhauling a system, which is difficult, it creates a lot of downtime, and it can often be very confusing, instead we can integrate different parts of a system or slowly create additions while still using our legacy devices, but instead increasing to newer devices that give us much more ability to interface not only with the product that's moving down the system, but also the pieces of the system themselves to make sure that we're providing the right maintenance exactly when we need it.